So today we're going to be discussing the chapter called as Polynomials from Additional Mathematics. So what is a polynomial function? It is a function that involves only non-negative integer powers or only positive integer exponents of a variable in an equation. So let's look at a few examples. So the first one is linear, meaning the highest degree or the highest power of any variable is 1. So in this example, it is ax plus b, which is a linear function, because the highest degree over here of the exponent is 1. So therefore it's a linear function, where a and b are constants and a is not equal to 0. So let us graph any linear function. So let's take 3x plus 4. So this is a linear function, and the gradient throughout the whole function would be the same. So it's a straight line curve, straight line graph with gradient 3 and y-intercept 4. So the next type is a quadratic function. We've learned that in the previous chapter what a quadratic equation / function is. So here it's anything in the form of ax squared plus bx plus c. So let us graph this also. Let's take 2x squared plus 4x plus 2. Okay, so we know that it's an upward facing graph because the value of a is greater than 0. So the gradient keeps changing, as you can see, and there's always a turning point for a quadratic function. Okay, moving on. So we're going to be working on the addition and subtraction of polynomials. In order to add or subtract two polynomials, we must collect the like terms. So like terms are terms for the same power to its variable. So over here we can add these two because the power to which the variable is raised to is the same. In both the cases, it's 1 and 1. So we can add the constants. So 2x plus 4x will give us 6x. So we could also add 2x squared plus 4x squared, which would give us 6x squared. And then we cannot add 2x squared plus 4x to the power 5 because they're not like terms. They don't have the same power on the variable. So, and the same rule applies to subtraction. So we could do 2x minus 4x, which would give us minus 2x, because 2 minus 4 is minus 2. And then let's try out an example. So we have to find p of x plus q of x. So we know that p of x is this and q of x is this. So let's add them. So 3x cubed minus 2x squared plus 4x minus 3 plus 6 x to the power of 6 minus 6x cubed plus 7x minus 10. So this is not a like term, so we can just retain it. So this is 1 and minus 6, so that would give us minus 5x to the power of 3. And then this is the only x square term, so you can write this. And then 4 plus 7 would give us 11x. Then minus 3 minus 10 would give us minus 13. And you could do the same for p of x minus q of x. Okay, so let me just work this out. So p of x is x to the power of 3 minus 2x squared plus 4x minus 3, and then minus of x to the power of 6 minus 6x squared plus 7x minus 10. So this would give us the following. So this would be our answer for p of x minus q of x. Okay, so let us do the multiplication of polynomials. There are two types. Scalar multiplication, wherein you multiply a function by a constant. So in order to multiply a polynomial by a scalar, which is also known as a constant, we multiply each term by the scalar value. So let's take this example. So it's 3 into p of x. So and the p of x would be this. And so 3 into x to the power of 3 would give us 3x cubed. Then minus 2 into 3 would be minus 6. 3 into 4 is 12. 3 into minus 3 would be minus 9. So that was scalar multiplication. Now let us look at polynomial multiplication. So in order to multiply two polynomials, we multiply each term of the first polynomial by each term of the second polynomial and collect the like terms. So this into this, and so on. So let me work that out. So we have to multiply the first by the first, and then this into this. So let's solve that. So x to the power of 3 multiplied by 4x would give us 4x to the power of 4, and then negative 3x to the power of 3, and then this into this and this into this. So this would give us minus 8x squared plus 6x. Then the final term, that's 12x minus 9. Okay, so now let's collect the like terms. That is our final answer, which is the answer.